So in this first video on forces on a slope, I just want to initially talk about the coefficient of friction. So a coefficient of friction is a value that shows the relationship between the force of friction between two objects and the normal reaction between the objects that are involved. It's a value that's normally used also in the physics course to find an object's normal force or frictional force when other methods are unavailable. So if we look at an object on a plane, so we'll stick with a horizontal plane at the moment, and we give that object a mass of m kilograms, then obviously that's going to apply a weight downwards onto the surface of mg. And the surface, given Newton's laws, would react with an equal and opposite reaction. And then that object will stay in equilibrium as it is. Now, when we bring friction into this system now, we then realise that in order to move the object, say, to the right, we need to overcome a frictional force which acts against motion. So it's very important you remember that frictional force is always opposite to the direction of motion. So if we think about this logically, there must be a direct link between the reaction, which is ultimately the weight acting down, and how big the frictional force is. As you increase the reaction force, the frictional force must increase in turn. In other words, there's a direct relationship. So if we were writing this in mathematics language, frictional force must be directly proportional to reaction. And in fact, to construct an actual equation, we put frictional force is equal to mu r, where mu is the coefficient of friction. Now, the coefficient of friction mainly varies between 0 and 1. 0 means that the surface is actually frictionless, and 1 means that basically the frictional force needed to overcome is equal to the normal force. Okay, most people think that friction is actually coefficient of friction is only between 0 and 1. That's not true. There are situations where it is actually more than 1. So if you imagine something like, say, silicon rubber, for example, this can have a coefficient of friction much greater than 1. So the frictional force is the force exerted by a surface when an object moves across it or makes an effort to move across it. So you've got to remember that if you're applying a force here in this situation to the right, it has to exceed the frictional force for this object to move. If it equals the frictional force, we get into a situation called limiting equilibrium. So for example then, if F is greater than Fr, we'll get acceleration because of the change in force. If we get a situation where F is equal to Fr, we get something called limiting equilibrium. That may well appear in your questions. And the final one, of course, is if F is less than Fr, and in this case, nothing happens. The object will not move. And that's technically the three situations that will occur when we start to examine forces on a slope.